I welcome everyone to day 5 of the C Bootcamp organized by the Cages Garage with the motto of Team Together Everyone Achieves More. It's a great pleasure for me to introduce our speaker today, Mr. Sumit Sir. He has command in various programming and scripting languages and is a very popular teacher with a vast teaching experience. Today we are going to cover pointers and recursion, one-day array. We will be taking up the questions in the last 10 minutes of the session. You are advised to share full screen to ensure the smooth flow, and also fill the feedback form and attempt the quiz in order to receive the completion certificate. Don't forget, we have a quiz organized for you, especially. You will receive bumper prizes for it. You are advised to read the new rules and regulations mentioned in the chat box. Please maintain the decorum. Any kind of wrong behavior will not be tolerated, and the person committing it will be no longer part of the C Boot camp. Happy learning, everyone. So please take over.
All right, thank you for the introduction, Malaika. Let me share my screen. Okay, is it visible? Can anyone confirm?
Yes, sir, it's visible.
Okay, thank you. So today's topic for this session is pointers. Before going to the definition of pointers, I'd like to explain what pointers are and why they are being used, especially in case of a system programming language like C, C++, and others. So, in case of C programming language, the memory is actually represented in the form of a single one-dimensional array. For example, this over here, this 1D array is represented as a memory. Means the compiler of the C programming language treats this your RAM or your computer memory in form of a 1D array. Now, whenever you write any program in C, what are the things that include a program? There could be some variables that you initialize. There could be some expressions that you write, like printf expression. There could be functions that you would use. There could be a data structure itself, like array. There could be strings. There could be structures, and so on. Now, if I talk about the very basic thing that is a variable, how do you think a variable is basically the value inside it is accessed by the C compiler? Let's say I declare an integer variable, int a is equal to 5. Fine. So now what your compiler will do, it will place this value 5 somewhere in the memory and assign it to a location. Obviously, if I talk about a memory, then there must be some valid location around it, right? So if this, let's say this value 5 is assigned at this particular cell, and this cell can be referred by any valid memory address. Let's say the address, for the sake of simplicity, I'm taking the address as 100. Okay. Usually the addresses are in hexadecimal or big unsigned integer forms. So now if you want to access this value, what you will do, you will directly write printf and the variable name. So what happens behind the scene? In order to access any value in C, you use the variable name. Okay, the simplest thing. Let me quickly draw this flow. So if you want to access a variable or a value inside the variable, first option is that you use the variable name of that variable, and the compiler does the job for you. So what behind the scenes, what the compiler will do, it will map this name, it will convert this name into something called as a logical address, and then this logical address will further get mapped with a physical machine address, that is the exact location. And finally, after mapping it with the physical address, you will get the value that you want. This is the whole process. Again, this is very abstract view. I'm simplifying things a lot here, but this is a general idea. So whenever you use the variable name in order to print any value, this is what happens behind the scenes. Another way is through something called as a pointer. Now, if you use a pointer, this pointer will, what it will do, it will directly hold the physical address of that particular variable. That means if the physical address of this variable A is 100, then you have this capability of directly accessing this value without converting it into a logical address first and without going through that mapping procedure. So because of this pointer, it will directly go to that physical address location in the memory and give you that value. So the whole mapping procedure, the conversion of logical address into physical address is not being done. And this is the major headache whenever your program tries to access, or whenever compiler tries to access the values or to fetch the values for you from the memory. This is the portion where a major amount of work has to be done. So this means this I have because of pointers, I have this capability to directly fetch the value from the memory, right? Because they provide me with some you can say some process through which you can directly locate that value in the memory address, right? Now let's jump to the definition of what pointers are and how they work. So a pointer is, as I explained, it is a special variable that holds the address of another variable. So a pointer is never being used to hold a value like a simple or a general variable. Instead, it is always being used to hold the address of any kind of variable, any type of variable, so to say. Now, you have already seen from my explanation before that what happens when I use pointers. It actually reduces the overall time. Whenever you try to access anything, if you are using a pointer to access that value, it will save the time, right? That conversion, that mapping from logical address to the physical address is not being done now. So the time taken to access a memory location is reduced tremendously because of that. Okay, and because of that, the overall run time or the execution time of that program, let's say the program is very big, it is a system program, a very big application. If we are using pointers at many places, it will significantly reduce the overall execution time of that particular application. So this is one of the major advantage of using pointer. Now, a pointer can be of any type. Just like your simple variable, it can be of type int, it can be of variable type char, array, or it can be also used with functions. Okay. And the last important point is this one: the size of pointer depends upon the architecture that you are using. That means whether you are using 32-bit platform or a 64-bit platform, the size of that pointer actually depends upon that. For some, it is 4 bytes. For some, it is 2 bytes. For some, it is 8 bytes. Okay, it entirely depends upon the platform you are working on. Fine. Okay, why to use pointers? I think I made this point very clear when I explained you in the first slide. It reduces the code and it improves the performance. You don't have to initialize a variable. You can directly use whatever the value you want to fetch. You can directly use a pointer for that, right? We can return multiple values using pointer to functions. The compiler internally uses a pointer to access array elements. Yes, I'll tell you, there is a strong relationship between array and pointers. Somehow they actually work behind the scenes. Their working principle is very much similar. Okay. Next point says that it helps you to dynamically allocate memory. It basically helps the compiler to dynamically allocate the memory. Okay, and same way it can be deleted as well. And through this, we can access any memory location that we want. We have direct access to the physical address. Okay. Now, next comes usage of pointers. There are multiple scenarios where pointers are used in C programming, especially the case of how you are going to pass your variables to a function. There is a concept of pass by value and pass by reference. So if you are using a pointer, then that a particular follows, or it follows a pass by reference model in that case. Next thing is, as I told you before, pointers and arrays hold a very strong relationship because their working is very much similar. So for accessing array elements, you can use pointers. Yes. To return multiple values through functions, if you are using a pointer to function, then you can implement that. Dynamic memory allocation can be done using different functions like malloc, or your compiler will also do it for you. To implement data structures, yes, and to do system level programming. See, the major stronghold of C programming is this only. If you see most of the system level programs or system softwares, like your operating system itself, they are always written in a low level language or a language like C, C++. Okay, and there is one more, Rust nowadays. So these are the popular system level programming, which has this concept of pointers, and they extensively use it. Okay, so now if I made myself clear about pointers, let's see how we can declare a pointer and how we can work around them. So I'll first write the code, and I'll show you example on VS Code then. Fine. So declaring a pointer is very simple. Just like you declare a normal variable, you can declare a pointer as well. So let's say if you want to declare an integer value, how you're going to do it? You first specify the type, then you write the variable name, and then you specify the value. In the same way, declaring a pointer is also very much same. You first write the type, let's say integer, then you write the name of that pointer variable. Let's say the name of that pointer variable is ptr, and before that you use this special operator asterisk. This is also called as dereferencing operator, or uh, there is one more a name to it. I don't remember it exactly, but this asterisk basically tells the compiler that this is not a general variable, a normal variable. This is a special type of variable, that is a pointer. And what kind of value it holds? It holds the address of a variable. Okay. Since this is a pointer of type integer, so you have to use it to hold the address of an integer variable only. So as I've already declared this integer variable a, now how to basically use the address of a, how to store the address of this variable a into this pointer ptr? Simple. Use another variable, use another this character, a special character, ampersand. So if you write like this, ampersand a, what it will do, it will directly allot the address, the physical address of variable a to this pointer. So let's say in your memory, somewhere in your memory, this is your variable a and it holds this value 10. And let's say the address to fetch this value for a variable is 1001. So if you write this line, then what this means? It means now there is a pointer ptr, and this pointer is directly accessing this memory location 1001. Okay, so pointers are used to hold addresses of simple variables, of general variables that we create. Right? And this is the simple step of creating a point, of declaring a pointer. Okay, let me open a VS Code and give you one example. I hope you can see my screen. So I'll work on side by side on both the screens. I hope these are visible to you. Okay, so here is the program to your left. You can see if it is not visible, it is not clear, let me know. I'll zoom in a little bit more. So what I'm doing over here, I'm declaring a variable. That variable holds an integer value 20. In the next line, line number 6 over here, I'm declaring a pointer variable of type integer. Okay, I already told you how to declare a pointer. You have to write the type, and then you have to use this special variable asterisk. This asterisk variable or dereferencing operator actually tells the compiler that the variable name after which you give after this operator is not a general variable. It is a special kind of variable which can only be used to hold the address of some other variable. Okay, so as I declare this pointer ip, now I can use it to hold the address of this variable var. Fine. So this is the way, using this ampersand operator, you can hold the actual memory location, the actual address of this variable var. Now, if you want to print, or if you want to see exactly what goes under this variable IP, you can directly do it using the printf statement. Just print it right away. Okay. If you want to see what where at basically the memory address that it is pointing to, what exactly lies there. In order to do that, again you have to use this dereferencing operator, this asterisk operator. Okay, let me run this program and then explain you the output. I think that would be better, and it will help you understanding this thing. Okay, let's run this program. So here's the output. Now let's read the output one by one and how it is getting printed. The first printf statement says address of this variable var is ampersand var. Now I already told you this ampersand variable is used to basically to actually store the address of of that particular variable, or to show you the actual memory address, actual memory location of that particular variable. So in this case, the address location of this variable var is this. It is a hexadecimal value 61ff18. Okay, it could be anything. It could be. It is usually assigned by your compiler and randomly. Okay. The next printf statement says address stored in this input, this pointer variable IP. Remember, the name of our pointer variable is IP. Okay. Now, what is the address of this variable? You just have to print it. Okay. If you just print this value, it will print the address of this variable. Okay. Means the value that it is holding. So IP is holding the address of var variable. What is the address of var variable? This one. So this, if you just print this pointer by its name, that's it, then it will directly print what it holds, and it holds the address of another variable, right? Now if you want to see that the particular address which it is holding, exactly what value lies there, so in order to do that, again you have to use the dereferencing operator or the star operator or asterisk operator. Okay, this is the dereferencing operator.
I have a doubt.
Yeah, go ahead.
So we can use percentage p instead of percentage x for address,
We can use percentage u as well, which means unsigned value. Okay.
and
Uh,
p also, and percentage p.
I'm not sure about C. Actually, I worked on C, to be very frank. I worked on C, I think 6 or 7 years back. That time we use, there is one more operator for printing the hexadecimal value. Just check which operator is used to print the hexadecimal value. You can use that as well.
Okay.
Okay. Yeah. So there are multiple ways to do that. Usually the address is in hexadecimal form. So just see which form, which operator gives you this ability to see the hexadecimal address, the actual memory location. Okay, fine. So I hope this example is clear. Very simple, right? In order to
Yes, yes.
access, yeah. So in order to access the address, use the ampersand operator. In order to see what actually lies in that pointer variable, you just specify the name of that pointer variable. In order to see what actually lies where the pointer is pointing to, or what actually lies at that particular memory location, use the asterisk operator. So if you just use this star operator, it will actually show you what is inside that memory location. Okay, so inside that memory location, we have a simple integer value 20. So that's why it shows you 20. Okay, let's go to the next slide. Pointer to integer. Now pointer to integer concept, it is just now we have seen an example of creating a pointer of type integer. It is the same thing. Let me show you another example to uh, clear this. So here is another example too. I'm doing the same thing here, nothing fancy. I'm creating a simple integer variable I with the value 3, and then I'm initializing and declaring a variable, a pointer variable j. How you identify that this is a pointer variable? Because I have used this asterisk, this dereferencing operator before it. Okay, and then the job of pointer is to store the address, to store the memory location of a variable. In order to do that, you assign this address of this variable I using the ampersand operator. Okay, so now j will carry the address of I. It's like that. If I show you in this form, so here I have declared a variable I and initialize it with a value 3. So this is I initialized with a value 3. Let's say, hypothetically, let's say its memory address is 1009. Okay. Now, in the next step, when you declare a pointer variable j, what this j will hold? This j will hold, since this is a pointer variable, this j will hold the address of variable I. What is the address of variable I? 1009. So inside J, we have this memory location 1009. Now, if you want to see what actually lies inside this memory cell, this location, to do that, use the star operator or asterisk operator. Fine, simple. So, okay, give me a give me a minute. Okay, I'll be right back. Okay, sorry for the interruption, guys. Let's continue. I hope my screen is still visible to you,
Yes.
right?
So
Okay,
could you
so
explain the last
mhm.
slide again, like what you just did after the output?
Where you're
So after the last, we did a code, right? After that,
mhm.
what you just explained, can you repeat that once?
Okay, after that, I've just explained this example that you see in, I think to your left it is. So we have declared a simple variable I. So here, through this diagram, I am showing you that there is an integer variable I and it holds a value 3 inside it. Okay, and I'm assuming that it has a simple address value 1009. 1009 is its address. Okay. And then we have declared another variable j, which is a pointer variable. And the job of pointer variable is to store the address of a simple variable. Okay. In order to do that, we use the ampersand operator. Now the address of I is 1009. So j will hold this value 1009 inside it. If you want to see what exactly lies at this memory location 1009, to do that, you have to use the star or dereferencing operator. Okay. So if you simply print J, it will give you the address that it is holding, that is 1009. If you print star J, then it will actually show you what
Got
value lies inside 1009. That is 3.
got it. Got it, sir.
Okay. Let me run this program. Maybe will make things clear. Over here. So as you can see over here, yeah, right here I'm using a different operator percent %u, which is for unsigned value, unsigned integer value. Anyways, it is showing you the address of variable I. How it is showing the address? Because I'm using the ampersand operator to print its address. Similarly, there is another way to fetch the address of I, that is through the pointer variable. So if you just print j, then it will automatically give you what it holds. It holds the address of this variable. So you see, first and second line of this output are same, right? In the third line of your output screen, it shows you the value that is inside that particular variable j. So in order to see the value that is there inside j, it will give you uh, just a second what it is. Okay, here I'm using ampersand j. That means this variable that I have created over here. This variable also has a memory location, right? This variable also has a valid address because I told you C programming treats every variable in the form of or the memory in the form of a one-dimensional array. So if let's say variable A lies over here at memory address 1009, then the pointer variable can lie somewhere around here, anywhere. It depends upon the compiler. Let's say this is the place for J, and J is holding this address 1009. And now J itself has a valid address, right? Everything that you write in your program, except the expressions, has been given a valid memory address. Let's say the address of J is 1020. Okay. So if you want to see this, if you want to see the address of that pointer variable, again use the ampersand operator. If you write ampersand J, it will show you the address where this pointer variable lies. Fine. This is what I'm doing in this third line of your output. If you want to see the value, since it again it stores the value of variable I, that is the address of variable I. It is 64222300. If you want to see what exactly lies at this particular memory address, that means if you want to see what lies inside 1009, in order to do that, use the dereferencing operator or asterisk operator. Okay, so in this particular line, I'm doing that. If you see over here, in both of these lines, here I'm directly printing the value. Here I'm going to the address of that variable using the ampersand operator, and then I'm using the star operator. The star operator gives you the ability to look into that particular address, that particular location. Okay, ampersand operator gives you the ability to fetch the address. Star operator gives you the ability to look into what lies inside that address or that particular memory location. Any doubt, anyone, in these two lines? How they're working?
No, sir.
Okay, fine. So let's move on to the next example. Okay, now there are a few concepts that are related to pointer. So this much is the basic part. Now there comes a concept called pointer to pointer. That means, let's say you have declared a pointer in, let me write it over here, int star x, and let's say this pointer variable x holds the memory location of a variable a. Now if you want another variable to hold the address of this pointer variable, okay, I'm repeating it again. You want another variable to hold the address of a pointer variable. How to do that? In order to do that, we can use a pointer to pointer. So a pointer to pointer will simply hold the address of this this pointer variable x. Okay, you have to write ampersand x. So it will hold the address of this variable x inside y. So if you want to hold the value of a pointer, hold the address of a pointer, use pointer to pointer. Okay, let me show you one example that will make things clear. So here is a pointer to pointer. I have declared a simple variable I. Value of I is 5. Let's say this is the location of I. It contains value 5, and let's say the address of this I variable is 1001. Fine. Next, I have declared a pointer variable ptr and assigned the address of variable I to that pointer ptr. Okay, that means this ptr now contains the address 1001. And I have also declared a pointer to pointer using this double star operator. Okay, means I have used this star twice. That's it. So it suggests that this is a pointer to pointer variable and it only holds the address of a pointer variable. So that means this ptr holds the address of I, and this ptr holds the address of this pointer variable ptr. Let's say the address of this pointer variable is 5000. So it holds this address 5000. Okay, this is how these are interlinked. Fine. If you want to fetch the value of I, simply print it. If you want to fetch the value of I through this pointer, use the star operator as you see in this line. If you want to fetch the value of I using this pointer to pointer variable, now it's tricky how to do that. If you want to fetch the value of I using this ptr, this pointer to pointer variable, can you tell me?
So can you repeat the question again?
I want to fetch the value of I using this pointer to pointer variable.
So what do you
Using
mean by
single
fetching
star.
the value?
Fetching the value means I want to get that value. I want to print that value.
Okay.
Whatever lies inside I want to print that.
So asterisk of pointer, then you will able to print the before pointer value. That is
So
101.
yeah. So this is my pointer to pointer variable. If you use a single asterisk before it, what it will do? It will peek into the value inside PTR. The value inside PTR is the address of variable I, that is 1001. If you use another asterisk operator, it will now peek into whatever lies inside this address 1001. What lies inside this address? 5. Okay, this is how these are interlinked. Let me run this code and we'll see. Okay, as you can see over here, all the 3 output lines prints the same value. So these are different methods of accessing or fetching the value of a simple variable. Is it clear? Any doubt, anyone? Yes, anyone? Any doubt? Let me repeat this again. If you want to get a value of a single variable using a pointer to pointer or a double pointer, how to do that? Use the first asterisk to go one level above and use the second asterisk to go another level. Okay. Actually, this chain can continue, depends upon how many levels you are creating. Okay. So this concept is can be extended up to maybe 8 times or 12 times. There is a limitation to it. I don't remember the exact limitation, but yes, this can be extended further. Okay. And usually in your higher education exams like GATE, these kind of questions usually come from pointer to pointer. Okay, how they work. So it is very important to understand the usage of this special operator, this dereferencing operator, how it works. Okay, so it basically what it does, it peeks into a memory location. Okay, or it gets you the value stored inside a particular memory location. Fine. Let's go next. Now, pointers gives you this ability to perform some arithmetic operations in C programming, and there are some limitations to it. Now, the things that are allowed using pointers are these operations. These are the arithmetic operations that are allowed: incrementing, decrementing, addition. You can do subtraction, and you can compare 2 pointer variables. Okay, one by one, we'll see the example of each of these. What is not allowed? Multiplication of 2 pointer variables is not allowed. Assigning a pointer variable a floating point value is not allowed. Why so? Because a pointer variable always contain a valid address location. And we all know addresses are either they are represented in hexadecimal or they are represented in a big unsigned integer value. Floating points are not allowed, right? Addresses are never assigned in a floating point manner. So these things are not allowed in arithmetic, pointer arithmetic. Okay. Let me show you examples one by one of each of these operations. Very simple. So here I am doing a simple addition and subtraction operation. If you see, and now you have to guess the output. You have to tell me the output of this. So I've declared 2 simple variables, A and B. Value of A is 6. Let me draw over here. Value of A is 10 and value of B is 6, simple integer values. Then I have declared two pointer variables, PTR and PTR1. So PTR points to this address location. Let's say the address location of A is 1002 and the address location of B is 1006. Okay. Another pointer variable PTR1 points to the address location of variable B. Fine. Now at line number 8 and 9, the printf statements are given. It says sum of 2 pointers and then it prints using this expression star PTR plus B. Now,
16.
how does it get
16,
evaluated?
sir.
16.
And next one is
Yes.
4.
And next is 4.
Next one is 4. Very good. So how it comes 16?
So star
PTR
PTR
Because the
means
pointer of
जो A की
Yes.
value है मतलब 10. 10 plus
Yes.
6 is 16 and 10 minus star PTR1 means B की जो value है.
Very good. Very
तो
good.
6.
Very good. So as I already told you, this star operator actually gives you the ability to look into, to peek into what lies inside that memory location. Okay. So PTR itself will take you to that memory location 1002, and if you add a star before it, it will give you the value that resides inside it. Okay, so this would become 10, and a value of b is 6 itself. So 10 plus 6, it is 16. Okay, and the next one is 4. Sorry.
Nothing, sir.
Okay, fine. You want to see the output? Let me
No.
run. Fine, 16 and 4. Fine. Let's see another pointer arithmetic operation. Here I'm using a for loop. Okay, this is interesting. Let me erase all this, and let's understand what is going on here. If you remember in the very first slide when I began explaining the pointers, I told you there is a strong relationship between pointer and arrays on how they work behind the scenes. Okay, let's understand that relationship using this example. So here I'm initializing a simple array variable. Its name is ARR and the size is 3. Okay, let's say this is my array variable ARR, and these are the values that reside inside it. And then I have declared a pointer variable PTR and a simple variable I of type integer. And now something interesting I'm doing. At line number 5, I am assigning this array to this pointer. Is it a valid operation?
Yes.
How it is different from a simple variable? In case of a variable, I use this special operator ampersand. But in case of array, I'm directly writing the name of that array. Right? What do you think is happening? Go ahead. Anyone?
So it will give you the 10 value 10 and it will be 0.
Okay, that means if I write PTR is equal to ARR, it will allow me to peek into the first variable itself, the first element itself, that is 10.
Yes, sir.
Okay. Any other answer? Any other volunteer? So here I'm writing PTR is equals to ARR. In case of variables, I would have written like this: PTR is equal to ampersand A. But this ARR is an array. Okay, and I'm writing like this. And pointers are used to store a memory address. They are never used to store a value directly. They are always being used to store the memory address. Okay, that means this ARR is actually inherently pointing to the base location of this array. Let me repeat it again. Array name ARR, this array name inherently, this actually holds the memory location of the base address of this array. What is the base address? The starting location, right? What is an array? Array is a homogeneous data structure which stores the values linearly one after the other. Okay? Similar type of elements. So the starting value, the starting address of that array would be stored in this array name itself. Let's say the starting address is 9000. That means if you try to print this value ARR, what it will print? It will print this address, not the value. If you want to seek the value, you have to use indexing, right? Got it?
No, sir. Please repeat it.
This array, the array name in any language in general, the array name refers to the base address. It points to the base address of your array. Base address means the starting address location, the starting memory location from where your array starts. Okay. So if you directly print, let me show you over here.
So if you give asterisk pointer equals to array, then it will print the 10, right?
Yes. Same thing I'm doing here. See what I'm doing, what I'm saying. If you write this printf statement, and if you want to see the starting or the base address of this array, then you can directly do it by writing the name of that array itself. What is the name of this array? ARR, right? So if I write like this, address of the array ARR is, and you can use star, let's say I use star u, comma, and if I write ARR directly, And let's see what it prints. So see over here, it prints an unsigned value of this address. The address which this array ARR is pointing to. This is the base address. This is the starting address of this array. Okay, and how these elements are stored? These elements are stored one after the other. So if the base address is 9000, and let's say the size of an integer is 4 bytes, then the next element would be stored at 9004, and then the next element to it would be stored at 9008. This is how addressing works in case of array. Got it? I'll not
Yes.
go deep into this because it itself covers one session itself. But yes, you need to understand this. Whenever you declare any array, the array name itself holds the base address of the memory location of that particular array. Okay, or the base address of that particular array. So if you want to access the elements of this array, either use indexing like ARR0, ARR1, ARR2 like this, or you can take the help of pointer as well. Okay, how to do that? If you see this simple for loop, I'm running this for loop from 0 to 3 since there are 3 elements, and I'm simply printing this value using the star operator. Remember, star gives you the ability to look inside what the value is inside that memory. Okay, so whatever the value is, it will print that value. It will print that element inside that array. So that is why 11, 12, 10, 11, 12 would be printed. Okay. You can use /n after that, so that output would be more clear to you. Let me run it again. So here you can see. So through pointer variable, now I have the ability to access array elements. I'm not using indexing. Okay, so this is another usage of pointers. Let me jump over to another example. What I'm doing here, okay, let me draw it over here. What it is doing, I'm declaring a simple variable number of type integer. It holds the value 50, and then there is a pointer variable p. P holds the value, the address of that variable number. Okay, and then what I'm doing, first I'm printing the address of this pointer variable p, and then I'm doing something special over here. This is p equal to p minus 1. Strange. I'm basically doing an arithmetic operation on a pointer variable. Okay, so if you see this, arithmetic addition and subtraction operations are allowed in pointers. Multiplication is not allowed. So if you write p equal to p minus 1, what do you think will happen? What
It
it will
will
print?
print the address minus 1.
The address minus 1. Okay, fine. Let's say the address is 1002. Okay, the address of variable p, this pointer p is 1002. If I do p equal to p minus 1, what will be the new address?
So 101.
Okay, let's say the default size, let me put one more thing. The default size of this pointer is 4 bytes. Okay, in that
Sir,
case,
998.
998, exactly. Okay, exact same thing is happening over here. Let me run this code and show you. Okay, so here it is showing me the address of this variable. This is the unsigned integer address 6442296, and I think it is assuming the size of this variable as 4 bytes. Again, it depends upon the platform itself, so it may be different for you. So based on that, it has decremented the address of that pointer variable. So now the address of that pointer variable p is changed. Okay, not the value inside it. Fine. Any doubt?
Can you say me the 46 bytes? Okay, if I minus 1998, can you explain that?
If I subtract how much?
Say minus 1, then it's coming 998 if it is 46 bytes. That's it.
Yes, yes. Okay, if you change the size of this pointer, then obviously it will change. Okay, if it is 6 bytes, then p will change to 996. Will get decremented by 6 bytes. Okay,
Okay, sir.
that
Okay,
I'm
sir. Okay,
consuming.
sir. Got it.
Okay. Okay, so now let's see another arithmetic operation, pointer arithmetic operation. So here is another example. What I'm doing here, I'm declaring a variable number with the value 50, then I'm declaring a pointer p, assigning its address to that pointer. I'm printing its address. Okay, so here I'm incrementing the address. I'm using the addition operation. So what do you think would be the output? Again, consider that the initial address of this pointer is 1002 and the size of this pointer is, let's say, 4 bytes. So if I do
1006.
6.
1006, are you sure?
So 100. No, sir.
Please
There is
repeat the
P
question.
actually. It will be
Okay, let me repeat the question again. The address of this variable, this pointer variable p, is 1002 and
so it
size
is
of a pointer variable
1018.
is 4 bytes.
114.
1018.
Okay, you are saying 1018. Someone says 1014. Any other answer?
1012.
1012. Okay, we have three different answers.
सर ये जो ये एड्रेस है इसी में ऐड करना है ना?
Yes,
तो सर ये होगा
1002.
308 होगा लास्ट में.
308 होगा. 308 कैसे होगा?
सर +3 है और जो इसकी बाइट्स है वो 4 बाइट है.
Correct. 4 byte means कि one address location holds 4
सॉरी
bytes.
सर मैंने गलत क्वेश्चन पढ़ लिया था. मैं कोड देख रहा था, कोड में से पढ़ रहा था.
Okay, fine. Let's see. We have three different answers. Okay, we are adding by 3 steps, and the size of this pointer variable is 4 bytes. Okay, so technically it should the new address would be 3 into 4. How much? 14 bytes. It should be far away. Means the distance between these two addresses should be 12 bytes. Okay. So the answer, I think you must have guessed it. What would be the correct answer? Anyways, let's run this and let's see what it is doing. If you see over here, this time the address of this variable pointer variable is this. In the last, it is last digit is 96, and if you are adding +3 to it, then it got changed to 308. How? Can anyone tell me?
Yes.
Again, it is assuming the pointer size is 4
+12.
bytes and +12. Yes.
So 1014 would be that.
Yeah. Fine. Okay. Let's move on to the next example. Example 8. Okay, what I'm doing here, I'm declaring a variable number, again a pointer variable p, and then I'm subtracting this time. Okay, so I think this will do just opposite of what you did before. Okay, so in this case, if the address of this variable is 1002 and you are decrementing it by 3 and the size of a single pointer variable is 4 bytes, then what would be the new address after doing 1002 minus 3? Simple, decrease it by 12 bytes. So 4 into 3.
88.
Yes. 988. Correct. Okay. Fine. It should be 998 actually. Because it get reduced or decremented by 12 bytes. Okay, so it should be 998. Fine. Let's run this code and let's see. So see, the initial address is, if you see this value 96, now it gets reduced by 12 bytes, so it becomes, the new address location becomes 84. Okay, fine. So these kind of arithmetic operations can be applied using pointer to a particular memory location. Okay, now pointer does not allow you to multiply, use the multiplication operator. Reason being, using multiplication operator is actually dangerous in case if this compiler assign a limited amount of memory for you to work on for your program. Let's say from 1001 to from this is the starting location for your program, and let's say the last address of your program is 110. 1110. This is the last address. Now, what is the danger of using multiplication operator? It actually multiplies the addresses. So in case if the value is huge, in case if the size of the, in case the number of steps that you are multiplying it with, you are multiplying the address with, if that value is big, then it may happen that the new value that comes may try to cross the range of the address that is set by your compiler. And in that case, it will go out to an external space, okay, where and it could be any unknown area. Okay, the compiler does not have any reach to that particular area, so it will not allow you to do that. It will throw up an error at runtime. Right? Because of these security reasons, multiplication in pointer arithmetic, especially, is not allowed. Fine. Let's see another example. So here I'm comparing two pointer variables. Very simple. I'm declaring two values, two variables A and B. Value of A is 10, value of B is 6. Then I'm declaring two pointer variables PTR and PTR1, and using a simple if condition. Using the dereferencing operator, I'm comparing their values. What lies inside A and B, I'm comparing those values. Okay. So obviously 10 is greater than 6. So the output would be value stored in A is greater than B. Let's run this code and see. Very simple. Okay, fine. Okay, let's move on to the next example. All right, so this is interesting. Here I'm using a different kind of pointer variable known as void pointer. Okay. Now, what is void pointer? Basically, if the type of that pointer variable is not specified, or if it is specified as void, then that pointer is a void pointer. Can you tell me by what is the usage of it? Why C programming has introduced it?
So it is because it was not declared any kind of variable, what type of variable it is, so it is written as void.
Yes, it actually increases the reusability of this variable, right? Let's say initially you are working with an integer variable. You want to store the address of an integer variable. So you can change its type from void to int using the typecasting. Let's say later on in your program, you are working with a character variable. So in that case, you don't want to declare another pointer variable to store the address for that character variable. You can use this void pointer. So this enhances the reusability of your code. Okay, so this is the main sole reason of using void pointer. Here is a simple example. I'm using a void pointer vptr. It holds the address of this integer variable I. Okay, and when you go and print its value, it will not be done as you did it before, like this. If you try to do this, it will throw up an error. Star. See, it shows you a syntax error. Void pointer declaration. Why so? Because it is forcing you have to specify what type of value it is inside the address that you are holding. In order to do that, you can use typecasting. So I'm using the integer value, so you can use int star. It means I'm using an integer type of value. So make this void pointer a integer pointer or a pointer to integer. Okay, so like this, if you run this code, now it will print the value using this asterisk operator. It will print the value inside this variable I. Okay. See, easy, fine. Any doubt, anyone? Okay, let's move on to the next example then. I think we are running past the time. Fine. This is another example. This is a different kind of pointer altogether. Okay. Here, this type of pointer, basically, if you initialize any pointer with this special value null, then it makes this pointer a null pointer. Okay, and this null pointer holds a value 0, and that is fixed. Right? So this is null pointer. Now, can you tell me what is the usage of it? Why C has introduced this concept of null pointer?
There is
Anyone?
no value, sir.
Yeah, there is no value, but what is the point of using it then?
We can store value later on.
Could be. Okay, I'll tell you one scenario. Let's say you are using some, you are reading some elements of an array, or maybe a big data structure. Okay, and let's say you are reading some data from a file through pointer. We already know how we can read the elements inside array through pointer. Okay, so let's say after a certain point, after a certain number of lines, you want to automatically uh, uh, terminate your program or whatever the values you are fetching. In order to do that, there must be a file break, right? There must be a break operation that has to be involved. So either you specify the number of lines in order to break, or you can use the help of this null pointer. So immediately after pointing to the last valid location, you change its value to null. That's it. So it will, the whole operation will stop here. It will not go further. Right? So this is just one use case of using this null pointer. Okay, let's move on to the next example quickly. Okay, so this is another concept that is introduced with pointer, that is pointer to function. Although pointer to function is not very widely used, it is not that popular, but still this concept exists. C allows you to make a function as a pointer also. Okay, in order to do that, you have to follow the declaration of a function. Just like you write a function, you first write its type, and then you write the function name, and then the arguments. The same way, you specify the type, and then the pointer variable, and then that function name, and then the arguments. That will become pointer to function. Okay? Here is one example of this pointer to function. So here I have declared two functions, fun1 and fun2, and the first function actually holds a variable in the form of pointer to function, and the name of that pointer to function is ptr. Okay, this ptr is a pointer to function with no arguments. See, nothing is there. If you want to add an argument, you can add a comma b or int comma int, whatever the syntax is. Okay, right now it does not have any arguments, so this is a pointer to function. Right, now inside my main method, what I'm doing, I'm making a call to this function 1, and inside this I'm passing this this second function, function 2. So using this pointer to function, this ptr now actually refers to the memory address or the address location of function 2. So indirectly I'm calling function 2 using this ptr pointer to function. Okay, now when you call function 1, it will first print this line, function 1 is called, and then I'm making a call to this pointer to function ptr, and I already know ptr holds the memory address of function 2. So whatever that is inside function 2 will get printed. So first function 1 is called will be printed, second function 2 is called will be printed. Okay, this is just one use case of using pointer to function. Okay, let me run this code. Okay, so basically pointer to function gives you the ability to hold the address of a simple function. Just like you declare a simple pointer to hold the address of a variable, pointer to function gives you the ability to hold the address of a function altogether. Right. These are some of the basic concepts that are involved with pointers, and usually questions are asked most of the time from double pointer, that is pointer to pointer, and there would be pointer to arithmetic operations involved as well. Okay, for most of the cases, for if you are preparing for placement, if you are preparing for any higher education examination like GATE, those questions usually come. You can go over to Geeks for Geeks and look for these kind of questions. Okay. Fine. The next topic of this webinar is recursion. Although recursion itself is a very vast topic and need a separate webinar for itself, but I'll quickly tell you in brief what recursion is and why we use it. So recursion basically gives you the ability, just like you write a simple iterative program, recursion gives you the ability to write that same program in a concise manner. And there is basically a way or a method to do that. The way is you have to work upon the logic, how it is working, and then using the simple the same method name, you can make that function call. So we often say that recursion means when a function calls itself. Okay, That is actually a method, a way of doing it. That does not define what recursion actually is. Okay? Recursion is simply simplifying the code, making the code concise, whatever you are doing, based on the logic. For example, I'll give you a very simple example of finding out the factorial of a number. So what is the factorial of a number? Let's say if the number is 5, what is the factorial of 5? So if you multiply this value all together with all the values that are less than or equal to 5, you will get the factorial. Okay, that is 5 into 4 into 2 into
120.
1. That is 120. Exactly. Okay. Now, if you are asked to write a simple program to find the factorial of a number, what would you do? You will simply use a for loop. You
Yes,
will
sir.
declare a variable fact, right? And you
Yes.
will run this from I equal to 1 to n or whatever that number is. And you will do fact equal to fact into I. Okay. And you keep on decrementing this value of I by 1. This is what you do in case of iterative version. But now what recursion does, as I told you, recursion helps you in making the code concise, writing the code, the program in a concise manner. Okay, you don't have to, you can write the logic of this factorial in a single line. How to do that? Understand this. In case of factorial of a number, what I'm doing exactly, I'm decrementing this value by 1. Okay, and I'm multiplying this value and I'm decrementing it. That's it. That is what I'm doing. So if you create a function, let's say fun, and let's say n specifies the number whose factorial you want to find, then using recursion, you can simply write it like this. Fun of n into, sorry, n into fun of n minus 1. Let me write it again. N into means whatever the current number is, multiply it with f of n minus 1 or fun of n minus 1. How it works behind the scene, let me show you that. Let's say I'll take the number as 3. Let's say n is equal to 3. Okay, and you want to find its factorial using recursion. So how this function call works. So in the first function call, you will see fun of 3. The value of n is 3. Okay, and then what I'm doing, I'm multiplying this 3 with f of 3 minus 1. What is 3 minus 1? 2. That means again there is a function call. So again a function call would be made, and now the value of n is 2. So now it will get multiplied 2 into f of n minus 1. What is n minus 1? 2 minus 1, that is 1. Okay, and let's say along with this you have written a base condition or a termination condition that if n reaches to 1, then terminate or then return 1. So this at this point of time, value of n is 1. So it will simply return 1. Simply return 1 means this expression becomes 2 into 1, 2. And it will get returned over here. So now this expression becomes 3 into 2. And finally, it will get returned to the root level or the topmost level. So the final answer would be 3 into 2, that is 6. This is a very brief explanation that I have given you for recursion, but yes, this is what recursion does. Okay, to give you an example, actually you will better understand recursion once you go through different algorithms first. When you know how to write algorithms, then only you can basically I would suggest you then only go for recursion. Okay, because the recursion itself is very vast. So just to give you a flavor of it, I'll show you one basic example. So this is the same example. I'm doing, I'm finding factorial of a number. So see, whenever the problem that you're working on, in case if you find some repeating steps in that problem, okay, if you find that the solution is repeating somehow, in that case, there is you are always free to use recursion in that case. Okay. Recursion helps you to concise your code. In case if the iterative version of the code is, let's say, thousands of lines, then the recursive version of that same code could be reduced to hundreds of lines. Okay. That can be done, okay? And that actually is happening. So this is an example of finding factorial of a number using simple iterative for loop. The same thing can be done through recursion by just writing the function name, and based on the logic, just make the function call. So both of these programs will do the same thing. Okay. Although this is a very basic example, but later on when you study sorting algorithms, especially like quick sort, merge sort, there you will see the usage of recursion, how it reduces the number of lines of code. Okay, fine. So I think that is pretty much it. Yeah, these are the this is the basic information about recursion. Yeah, okay. So any doubt, anyone?
No, sir.
All right. If you need any help anytime, especially in the topic of pointers and in the topic of recursion, or if you want any resources, although lots of resources nowadays are available, but if you want something from me, feel free to contact me. Okay, I'll be happy to help.
Thank you, sir.
All right, thank you.
It
Thank you
was an
guys for having me. Yeah.
it was an amazing session. Thank you for preparing such a nice presentation. Anyone has any kind of problem or question, please ask. And don't forget, we have a quiz planned for you. So if there are no questions, we can go ahead with that. The link will be mentioned in the chat box. Please attempt the feedback form and the quiz in order to receive the completion certificate. Thank you everyone for joining in. Hope to see you all tomorrow.